Hi, I'm Nils, Director of Machine Learning for Cohere. I'm not a coffee drinker, which surprises a lot of people, but more like hot chocolate. So this keeps me awake, especially in winter. Get a good hot chocolate in the morning, and then you're up and ready to do more machine learning.
Welcome back to another MLOps.community podcast. I am your host, Dimitri Os, and today I am joined by none other than Abby. What's going on, Abby?
Fantastic. Very interesting conversation today. But Nils, I forgot how we pronounce his name.
I actually like the idea of Nils. I was calling him Nils, but I think at the end of the day, you could go for both. I mean, who is Nils or Nils?
He's the director of machine learning at Cohere. Very interesting background. So he started working in machine learning research, but very specifically in NLP research back in 2014 when the field wasn't that hot. There was some work around GANs, which was starting to come up in the field. But since then, he has done some really amazing work around search spaces, around multilingual search. I think one of his work, which is SentenceBird, became quite popular in the community. And in the past, he's worked with HuggingFace, and now he's with Cohere. So very, very interesting conversation. Very interesting person to have this conversation.
So I really enjoyed his whole outlook. I mean, let's preface this. He gave us a ton of information about what Cohere is doing. And Cohere, I was very interested in talking to because they're one of the few companies that I feel like are actually doing LLMs in production at a large scale. And it's the different kind of production than I think a lot of people are actually doing LLMs in production. And I use my little fingers to do the air quote with that because there's different types, right? And this is something that we talked about a week ago on the LLM in production roundtable. And one type is just building on an API. Another type is maybe potentially chaining together a few API calls and maybe hot swapping models or APIs that you're using. And then the other is getting these models and really going in and fine tuning them and actually like doing the work or building the model yourself, which is what Cohere is doing, and training that model from scratch. And then they're the ones that are exposing these APIs to the rest of us. And so I think that's fascinating to hear like what the challenges are. And I love that he went over, we asked him some of these core challenges that a lot of people have been talking about. One being cost. And for them, when they think about cost, they're not only thinking about the cost of serving these models to the public through their API, but there's the cost of actually training and staffing up the people that know how to create these models and then all those GPU resources and all that good stuff. And then the other idea is latency. That's another huge one. So he went over both of those. I thought those were excellent answers. Was there any other key takeaways that you enjoyed from this conversation?
I loved their product focus very specifically when we asked him the question, which is, are you focused on how do we build a bigger foundational model at this point in time? And what are you reading in that specific area? Or are you focused on the apps and everybody who's building products on top of the models that you have? So that was one conversation which I loved, in which he said, it's time to because we have to make money out of these models, it makes perfect sense to be able to understand it. What applications are people using them for? And prep-wise to that, also the conversation around security, because that is one thing that enough people are talking about. So those were two highlights for me.
Security always gets the short end of the stick. No, there's never enough people talking about it until there's a huge security breach or hack or something, and then it comes up for a few days and then it goes away again. But there is this predicament that I think a lot of these foundational model providers are in. One being that they're competing against the likes of Google's and Facebook's, who have basically endless resources to put out these foundational models that they're creating. And they can, if they choose so, like we've seen with Facebook recently, right? And Google in the past, they can just open source those models. And then they're also competing against the likes of OpenAI, which has really just taken off. And I think if most people are building on top of large language models these days, it's probably something to do with GPT-3, GPT-4, whatever the new GPT is. By the time this gets released, potentially we're at GPT-20 with our release schedule. But the idea there is that I think it's fascinating because they don't, like the Facebooks and the Googles have the foundational models as almost like a side business just to stay up to date and stay current. And all the R&D that they're doing is something fun, but it is not core to the business that is just printing cash.
Yeah,
And
it's
so
R&D
Cohere,
specifically. It's not the product for them.
exactly. And yeah, and when you look at some companies like Cohere or Anthropic or Adept, these companies need to figure out the business model around the large language models, which is a whole different game. And so I'm fascinated to see how that plays out in the future. And when you think about this in 2 years, or you think about this in 5 years, what is that going to look like? And so I think Nils brought up a great point around that when we asked him, what's your differentiating factor? How are you at Cohere trying to separate yourself from the rest of the foundational model providers? And I felt like he had a spot on answer for that. I don't want to spoil it for anyone, so I'm just going to leave it at that. Listen, it's kind of at the end when he talks about it. Enjoy. And if you are not already signed up for our newsletter, if you're not already going to one of our local meetups that are happening in all of 37 cities around the world, so there's probably one not too far from you. And that's it. Let's get into this conversation with Nils.
And to give us the reviews, otherwise Demetrius will personally message you and chase you to write a 5-star review for us.
Oh, that's so true. The people underestimate my ability to be petty. So I will find you. We love reviews, and we love it when you write funny reviews. If you have that possibility, it would mean the world to us. Let's jump into it. So, Nils, you are very close to me. I'm surprised we're not doing this in person, actually, because you're only like 40 minutes down the road from my house.
Where are you located?
And I'm in this little town right near Bad Schwalbach, and you're in Frankfurt, if I'm not mistaken.
Darmstadt even, so it could be even closer.
Oh, okay. Even closer, dude. So yeah, we'll have to meet in like Wiesbaden for some pizza or something sometime, and I'll practice my horrible Deutsch with you. But today we're here to talk all about large language models. I think it's worth just going over a bit of your background because you've got some interesting pieces. I mean, you did a bit of IT security that I want to get into and how that relates to what you're doing these days. And then you went and did a Ph.D., but I'll stop talking and let you tell us what exactly your history is.
Yeah, really happy to be here. As you mentioned, I did a lot in the past, so I kind of like to pivot and do like every 5 to 10 years something different. Originally, I started in web development, doing a lot of software as a service business, creating my own companies and co-founding companies with people in the early 2000s when software as a service was not like a business concept, so it was like an unknown term. After that, pivoted into IT security, a lot of cryptography, a lot of algebraic stuff, understanding security systems, how to set it up, how to test it, how to pen test, and also how to break it. And then in early 2013, pivoted to AI and machine learning, which was a completely different field at that. So it was there was basically no business interest in machine learning. Only really few, maybe Google is doing machine learning at that time. But it was an interesting field. And then really in the past 10 years, totally changed. Now you see what I'm talking about. My grandparents know about ChatGPT and Transformers, stuff like that, because they read it, I don't know, in the Time magazine or saw on some news show on TV. And yeah, really happy to be in this field.
Yeah, there's a bit more hype around it now than there was in 2015, I imagine.
Yeah, definitely. So especially NLP, like when I started, no one knew, okay, what's NLP and why do you use it? Some said, yeah, maybe named entity recognition on news articles. That's interesting to know. Which companies are people talking about, and how is the perception of, I don't know, JP Morgan versus Bank of America?
Yeah.
But no one was like really interested in NLP. And yeah, like last year, this year, now everyone talks about like natural language processing.
And it became the hot topic.
True.
For sure. So what prompted you to make that switch from IT security to machine learning?
Yeah, so I finished my master's degree in IT security, where I did like a lot of theoretical stuff in cryptography, doing like certain proofs about security conditions that cannot meet at the same time. And the challenge with security is it's really abstract. So if I asked you, you spent maybe, I don't know, $100 for McAfee antivirus software, some antivirus software. Was this $100 like a worthwhile investment for you in the past year? And you say, I don't know. I spent the $100. Was it worth it? Should I spend next year $200 on it? Should I upgrade? It's like really, really hard to say, because security, there's like not really, you cannot measure it. Like, is there like a return for you? And where I said, okay, I want to go back more hands-on and say, go in a field where you see that's valuable. So it's like kind of you build something which you can touch. And so went back to like machine learning. Had in university a really great class in Berkeley, Introduction to AI, where Professor Dan Klein was like introducing all the concepts on Pac-Man. So like the whole semester we're like programming Pac-Mans, making Pac-Man smart, making the ghost smarter. So how can the Pac-Man automatically avoid the ghost and eat all the bubbles, and also do like tournaments where you have like two teams competing each other, so who can like fight the other teams and eat all the bubbles from the other side of the board, which was super fun. And it kind of had like these feeling you build something which you can't touch. So you see how the agent starts really stupid and runs into the ghost, and then with every iteration you make it smarter and smarter. Where I said it's super interesting as an engineer on the one side, as a software developer on the one side. And at that time, so in early 2013, I said, if a computer can really understand text, it will be extremely powerful. So we have all our human knowledge captured in text. So if you think about like how much knowledge there's in Wikipedia, on all written books, on all news articles, if a computer understands this and really has read every single Wikipedia article and be able to understand it, like how smart can the computer be? And I think it's always good if you're smart, or if your computer is smart. That's always valuable in our society. So I was really interested to dive into that.
So true. Yeah. So it sparked that flame inside you. And it's funny you say that the IT and security in general isn't as tangible, because I could see that, like, oh yeah, did it work? Did McCaffrey actually do anything? Or is it that I just like was not targeted? And I guess you don't realize you need security, or the beauty of having these security programs, until the day that you get hacked, and then you can put a price on it, and then you're like, oh man, I'll pay whatever.
But yeah, you never know if you catch a virus, get hacked. Like, would it have been changed if you would have upgraded to the more expensive antivirus software? And also, and in a business context, it's even more challenging. If you're a bank discussing, should we upgrade our encryption standard, go from 128 to like 256 bits keys, will it make a difference? You don't know. And that was a bit sad for me. So I really like it when it's tangible and you can say, hey, that's amazing. That's people want more. They use it. They love it. The usage increases. So that's what I like a bit more to do. But yeah, obviously security is super relevant, and also in terms of like language models, also really hot topic, interesting field.
That's exactly where I was going with this. Like, how are you bringing what you basically have innate, I imagine, from all those years being in the security field now in what you're playing with the machine learning and more specifically NLP?
You see a lot of challenges coming up with these large language models, generative models. On the one side, if you train them, there are like certain challenges like data set poisoning. So people try to sneak in like harmful content into the training data sets. Personal information is a challenge if you have like these generative models like, hey, what's the private number, phone number of that person? It should not reveal like this number. And external factors for people misusing the models to create like personalized spam, to either flood Google to put advertisement on it, or to do like targeted phishing campaigns. Say, okay, yeah, I follow your comments on Reddit and now I send you like a targeted automated phishing email on this. It has many interesting upcoming security challenges in that field.
There's like not only like the security that's happening inside of the models, but also how I imagine bad actors can just augment what they're doing with the new found capabilities of these large language models.
Yeah, I mean, the goal of these large language models is to make us more productive. So to automate boring, uninteresting tasks away. Like, I don't know, writing reports, or I don't know, maybe you have like these 3 bullet points, but you have to make it in a like nice long written application, because that's kind of like socially expected that you're not sending like 3 bullet points where you're amazing, but have all these boilerplate when you apply for a job. But yeah, sadly, it also makes the bad actors and people with bad intent more productive. And so that's always like a balance we have to find as a society. How can we make the good people more productive and like try to reduce the risk of making also the bad people more productive?
And is that something that you're focusing on right now as you've been working in large language models, especially like because the scale has increased massively and there are more people building applications on top of them? Or was this also a concern for you while you were doing like your PhD?
And during the PhD, it was not so much of a concern. So during my PhD, it was more like text understanding, like find, I don't know, named entities in news articles. And there, not so much bad intent can be derived. But we really, with these generative models, you see a lot more interest. And at Cohere, it's also like a big interest on the one side, how to avoid that harmful content gets into the training of our models, and that personal identification like credit cards, security numbers get into the model and reproduced by the model. How can we avoid that the model is not being used to like hate speech, producing hate speech, so that you're flooding social media with like generated hate speech? But it's kind of like hard and trade-off, because also security principles, there's a trade-off. For example, people want like data privacy, so they don't want that model providers spy on how are they using the models, but what use cases and what text do they produce with it, because it can also have like sensitive information in it. But if you ensure like these privacy, you cannot find like bad actors that's creating like a phishing attack and try to mail 1 million users, 10 million users with like really personalized spam to do like phishing and try to get like credit cards from it. So you have to do the trade-off, like either you respect the privacy of the users, and then you can't avoid like the bad actors, or you say, okay, you are more light on privacy, and then you can prevent better like these, or identify these bad actors that try to misuse the models. From a society perspective and regulation perspective, it will be interesting how to deal with it, like how to go forward. Also from a society perspective, how do we need to evolve? Like with every technology, there was like misuse, like when email came up, spam came up,
so true.
which you didn't know from like classical written letters. But yeah, people evolved. No, okay, yeah, I should not trust like every email I get. So if I get like an email, presumably from my bank, claiming, "Hey, please enter your password here," we hopefully learned as humans to not trust it, and then we just need to also evolve and see, okay, what can we trust and what can't we trust, and what like new trust measures. you can implement.
Yeah.
Yeah.
Dude, so there's something else I wanted to ask you about, because you basically were hanging out in academia for a while and then you moved on to industry. And what made you want to take the plunge into the industry and start getting your hands wet, like trying to make money with machine learning as opposed to trying to write papers about machine learning?
Yes, so I love building stuff. So that's what I did for 20 years. Early on, be like a really big contributor, even like 20 years ago for open source community. Maintain and manage and set up so many open source projects. And yeah, and in science at some point when I made the move, I said, yeah, it's I like more on building stuff than writing the papers. So writing really scientific papers is a lot of overhead, and it's not really focusing on what's useful and what's helpful for users. So the incentives is different. So you have to write the paper in a really specific format so that it gets accepted, but it's not really what's helping the user the most. And often what's helping user the most, it's not publishable. So for example, one example in the field is like the reporter paper from Facebook, where team from Facebook was working to make BERT better, understand BERT better, train it on more tokens, get out like a better model, which is used by millions of companies, the Roberto model, so extremely helpful. But when the team submitted it as a paper, the scientific community said, no, we reject it from this conference because it's not novel. It's just BERT trained on more tokens and optimized. And I didn't like this disparity that you say, okay, this is like what really helps and has a massive impact on users, and it's not really honored by the scientific community. So, and I said, okay, let's go really build stuff that's helpful for users and don't care if 3 random anonymized reviewers like it or not and decide if the paper will be accepted or not.
Very interesting. And something you did talk a little bit about before this, when you said, one of the main things that we need to look for is how are users interacting with these models and what kind of information are we gathering using these models, because we're constantly training the model on the information or on the type of use cases that people are using these models for. So one of the things that happens, and this is something you also gave a talk on, which is basically stale models are a major issue. So do you think that, and because yes, we're working with deep learning, and one of the major flaws in deep learning has been catastrophic forgetting, do you think catastrophic forgetting then becomes a feature or a flaw when developing new models?
Yes, so that's the interesting topics, many aspects on this. First, like stale models is a challenge. If you ask a BERT model, BERT doesn't know anything about Corona, so still thinks Corona is a beer. But if you ask a model like, how do I catch Corona? Or what's the transmission of Corona? Still thinks, yeah, how do I catch a beer? And sadly, happily, it doesn't know like about connection to COVID-19. Also, if you put in like in a generative models and let's say, hey, write an article about the political career of the US president, and then the BERT model still thinks that Barack Obama is the US president. So it outputs you like the political career for Barack Obama up to like 2017 or 2018, which is kind of frustrating. So it's a big question in the field is like how to update it. Catastrophic forgetting is in general a challenge also when we add more and more capabilities to it. But as we see, as the models become really large, they typically have like enough capacity. So if the models have like 10, 100 billion parameters, catastrophic forgetting is not that much of an issue where you say, okay, add like a new feature, now it can summarize, or it can code, or it can talk like a pirate. It's not really forgetting that much of the past. But really the updating of the knowledge is tough because we humans, we're super efficient. So if we read on New York Times, I don't know, the next US president election, this person is like the newly elected president, we can update our knowledge from this single example. But these generative models, AI models, they sadly have to see like millions of these occurrences. So it takes like a lot of data to update one single simple fact about like who's the current US president. We're also really good in updating, making connections. So we know this person is the new US president. So we know, okay, First Lady is changing, who's like the ruling party in Washington is changing. So we're really good to make all these connections from like, I don't know, like 5 words. The generative model maybe can update the new US president, but then still thinks the First Lady is the old one, or doesn't know like who's like in charge of the White House. So what I'm more interested in is like really combination of like search technologies and generative models. So that's an exciting technology where we currently in these big models, generative models, we have kind of stored all the world facts. So they know about like every country, every capital, presidents and majors, and I don't know, actors in movies and so on, which making it really hard to keep it up to date. And I think an interesting trend is like where you say, okay, well, you train these generative models just to be good on reading comprehension. So it can read text and then reason on the text, and then plug in good search components. So if I ask like, hey, write an article about the US president, it would first go on Google search, find current US president, open Wikipedia, see, okay, this is the Wikipedia article of the current US president, and then based on this article, produce the output.
You mentioned the 2 ways of going about the solution. One is we train the next model on lots of data, and one of the main reasons for that is because these are probabilistic models. So the probability depends on the number of articles it has already seen in the database that do resonate with that kind of result. And the second is basically something you said, which is the search as a way to be able to update your information. Which categories is it better to use one approach over the other when we are incorporating this new knowledge into large language models?
Those are still like really early. So it's not like really that the one or the other works well. Me personally, I like the search one more because it updates a lot quicker. So when you think about how quick editors on Wikipedia are and be able to change anything. So I don't know, a monarch like Queen Elizabeth passed away last summer. Within a second, it's updated on Wikipedia, and it's not really feasible if you try to put this into the model and update it, because it's only like a single data point that Queen Elizabeth passed away. So it's not really just says, okay, that's noise. I will ignore it until I see it like 1 million times. And it takes really long until you got like 1 million articles talking about Queen Elizabeth passed away. If it's something more minor, so I don't know, there's like an election in some tiny city and the mayor is changing, it will take a really long time until you have enough text. And with search, you can always, if you have search index up to date, if you always pin to like the most up-to-date Wikipedia, you have like these instant updates. So as soon as you, like 1 second after Queen Elizabeth passed away, you ask the model, hey, can you write me a summary about the life of Queen Elizabeth? It then can produce the output. She passed away on whatever date it was.
One of the things I think of when thinking about this is basically how do we define the neural search space and build adaptive models that are able to adapt to different kind of scenarios. So one of the reasons for that is it depends on, let's say, if we're making a search which is information retrieval, and what kind of information retrieval is, whether we're looking at facts or are we looking for, let's say, code. And for code bases, again, for the kind of use cases that GPT is trained on, it's perfectly reasonable to be able to look into like the historical data instead of like the new word data. I don't think it makes that much of a difference. Or to search for like what's new on Stack Overflow.
Yeah, I would disagree on this to look in code and historical data. Yes, in certain use cases, it's fine. Like if you think about like primitives in Python, like how do I define like a function, if statement, a loop, that's okay to have these historical data. But then if you work with APIs and frameworks, there are like new versions coming out, and then maybe some popular framework, I don't know, like Scikit-learn is putting out like a new major version, or PyTorch put out like version 2. And you ask like, hey, how can I create like this module in PyTorch? Maybe in the historical data, it just knows like from version 1 how to do it, but it doesn't have like these up to date. And then it would be nice. I mean, that's what we as humans also do. So we kind of remember something, like how to do basic stuff, but also a lot of things is like Googling, checking up, or taking the IDE and see, okay, what were like the parameters again for this function in PyTorch or in my favorite framework. And then also, it's nice because we see, okay, this is the version I'm using, or that's the latest version. I can directly update it as a human. So I would not advise my engineers to say, hey, remember and memorize everything on these tutorial, on the documentation of PyTorch. I say, no, learn how to search, what to search for, when do you need to search, and take the search into account. And that's what we do with generative models. So at Cohere, we're teaching them how to search, like really be able that they know, okay, this is a gap I should check. Use Google, use Amazon search, use internal search to find the relevant information, post the right search query, and then be able to reason on what you find there.
It feels like that is a really good use case for putting some kind of catching model before it actually goes to the large language model, where this model can filter out, should this be searched for, or should this go directly to the large language model?
Yeah, that's a challenge in terms of pre-training. So right now, pre-training is like just next token prediction. So I say the current US president is, and then the model knows, okay, I need to predict the next token, which is already a challenge in the training data because I don't know from when is the training data. Is it an article from, I don't know, 2005 or 2015 or 2023? And then also I like with search in the pre-training to know, okay, what should we search for? So it's still many open questions. How can you also adapt the search to the respective time? So if I pre-train on an article from 2015, how can I have like a snapshot of Google, for example, from 2015?
Just like thinking through this in my head, it would be very hard to know what these topical items are, considering that they're always changing. Like you said, like Corona, all of a sudden something like Corona comes up, and whereas before that wouldn't have been something that the model probably would catch, now it needs to be. And so you need to figure out those ways to quickly switch in these topical issues and make sure that you can stay up to date. Changing gears a little bit, I know that one of the other very hot topics when it comes to dealing with large language models and actually like using them in production is the latency issue. And we had Sahil on here from U.com, and he was talking about something that I thought was fascinating, which is the actual non-subjective time that it takes to get some answer back, and then the perceived time. And they're doing all kinds of cool tricks to make the perceived time feel shorter. So maybe they give you some kind of quiz while you're waiting for the answer to come back, or they tell you some fact, or et cetera, et cetera. So it occupies you, and then you go, oh, look at that. Before you know it, there's my answer. I'm wondering about what are the technical things that you all are doing to make sure that the latency stays down, because if you're not very, very on top of that, it can get out of hand really quickly.
Yeah, so that's an issue with big models. It has a lot of hardware requirements. Really like here what you say, perceived time, actual time. So one feature we recently launched was like streaming. So you say, write me a blog post about the monarch of England, and then so before that we were like producing all the output and then send the output as a chunk back and say, here's your article. We change it to streaming, so as soon as a word is generated, it's like streamed back to the user, so you can start reading, and then you see, okay, the article starts to write. Within a split second, you can already start reading. And then the latency, perceived latency, is a lot smaller. So if the model can produce quicker words than you're able to read, you're not perceiving any latency. So you're not fighting, especially with long generated text, like, hey, you have to wait like 10 seconds, 20 seconds to get the article. But you see, okay, it's producing, you can start to read, and you probably need more than 20 seconds to read it anyway. That's on the one side, like the psychological tricks, you can make it to perceive it faster. Other sides to make the model be actually faster. First is like model size. So the smaller the model, the better. But this is like in conflict with the quality of the model, where we see, okay, larger models are totally more capable. Hardware optimizations. So the field moved away from float 32 to float 16, is now moving to like int 8. Also NVIDIA with the Hopper H100 GPUs showing float 8. So where you see, okay, float 8 is, I think, something like 4 times or even more faster than float 32. And then there are certain other tricks for machine learning. So where you run like 2 models in parallel, like a small model that creates like a first draft of the article, and then a second model, the larger model, that's kind of rates this and then takes the input from the smaller model as the input to navigate the search space. And there we also see like good improvements from that. But in general, a challenge is like, deploy it, and how well does it work with like perceived time, especially in a streaming setting where you say, okay, maybe this optimizes the end-to-end time, but it's not compatible with like streaming, so with a perceived time. So there you have to find like trade-offs again.
And I have a quick question, because you said you would have 2 models running in parallel. Would they be running in parallel, creating 2 different outputs at the same time, or are you thinking about using them as like an actor critic?
So a challenge with these generative models is you have a token, and then you predict at the output, out of these 250,000 tokens, or whatever your vocabulary size is, which one is the most probable next one. So that's kind of a challenge, that you say, okay, you have like these 250k tokens at the output to really say, okay, these tokens should be the next one. And here you're using like a smaller model to not predict like what are like the 250k tokens, but you say, okay, use the small model, do the prediction, and then you go like the top 10 tokens from the small model. And the larger model just needs to see, okay, from these top 10 tokens, which is like the best one.
Okay, that makes more sense. And for problems, while that's understandable for text, what would be the big problems according to you when we start going into the territory of, let's say, multilingual search? Because search in just like a single language is a little bit easier, but when we have more modalities or when we have more languages, it becomes a little bit more complex. Like the search space becomes exponential.
For generative models, typically what you do is like increase the vocabulary. So often for English, you have something like, 50,000 tokens you're searching over. And then in a multilingual setting, you increase it to like, 500,000 tokens. But it's still doable.
So let's keep moving. And I want to dive into a lot of the work that you're doing right now at Cohere. And let's just start by laying the foundation of what it is exactly that you're doing at Cohere, and maybe even for those who do not know, because I know there may be some people out there that have not even heard of Cohere. So can you give us a breakdown of what Cohere is and what you're doing there?
Great. Yeah, sure. So Cohere is a Canadian company founded back in 2019 from one of the co-authors of the Transformer papers, Agent Gomez and friends, where they saw like a lot of transformation within Google, the Transformer architecture and the BERT architecture had, and said, okay, yeah, this should be more widely accessible to users. And Cohere, we're training foundational models in NLP. One is generative models. You give text in, like write me a blog post about MLOps and focus on security. And the other is text understanding, which I'm in charge of, be able to, on the one side, search on text, recommend text, or understand what's written in the text. Let's say you have customer reviews, 10 million customer reviews. Say, what do they like about your company? What do they dislike about the company? So how can you go from these 10 million customer reviews to actionable insights to say, okay, these are like the top 5 complaints our customers have. These are the top 10 feature requests we have. So that you can really have these insights. And yeah, an interesting direction is the combination of text understanding with generative models. So if I ask whatever generative models you're using, like, hey, what are the top feature requests users of my company have? The model maybe makes up something where it says, sorry, I can't answer this because it doesn't have like any insights on your company and what the 10 million users want. And here an interesting direction is really you plug it into your public Discord, to Twitter, to, I don't know, some survey you run and say, okay, here's like everything my users are chatting about, talking about. What are the top features they do and how can we implement it? And then you have first a search phase to go over like 100 millions of messages you have from your users in different channels. Narrow it down to say, okay, these are the top 10 features users requested and interested in. Like, for example, improve the latency of the model. And then the generative model says, yeah, so a top requested feature from the users is improve the latency of the model. There are like different ways how you can improve the latency of the model, faster hardware, distillation, quantization of models command. So you have a really grounded in some facts and some knowledge.
And are you, and just so it paints a bit more of a clear picture, are you all exposing an API and expecting people to build on top of Cohere, or are you planning on building everything yourselves?
So we're providing these models as an API. So there's like one side as an API, you get an API key, you can request it. Say, okay, there's like a search model, and then you can build like a really nice search function across many languages. Or a generative model, you give in the prompt, you get the output. The other option is like on-prem deployment. So currently we're on AWS SageMaker, where you can take the model, host it in your own environment, was connected to data privacy. So there's like no risk that any sensitive data is going away from your cloud environment. And we're adding like more and more capabilities, like really teach the model how can they search and reason over, let's say, your 10 million customer reviews. But obviously you still need to, it's a tool for developers, so you need to bring it still into your product, see, okay, who do you target? Is it like a B2B, B2C? And what do you need to build? So it's a building block for you as a developer.
Yeah, makes sense. So correct me if I'm wrong, because I've had this use case in my mind for the MLOps community that I've been wanting to do for a while, and I think we'll probably do it with some kind of hackathon later on down the line. But there's a lot of podcasts out there of the MLOps community that we've put out, and potentially we transcribe all of those podcasts, and then we can search them, and we can have that indexable ability. And there's a lot of conversations and great threads that have happened in the MLOps community Slack. So potentially with Cohere, we would be able to plug that into our Slack, or we would feed all of our data to Cohere, and then it would give us those insights that you're talking about, and we would be able to search and ask things of it.
Yeah, so for search, technically how it works, there are like two models. One so-called embedding or vector model. So it takes the text and understands the content of the text and transforms it into a representation that's understandable for a computer, which is like a vector. And that's what you combine with a vector database like VV8, Pinecone Current. So you say you take all the podcast description, get the representation that's understandable for the computer, and put it into your vector database. And then you already can build like the first valuable thing, like a search bar, as you know from Google. You can type in and say, when did they talk about security in large language models? And then it will pop up the right podcast, say, okay, here in minute 15 to 20, they are talking about security in large language models. And then the next step, it's still in a really early research, is like plug it into a generative model so that you can reason about like in text. So for example, a big challenge is identifying personal information in text. So you could ask like, okay, what are like ways to identify personal information in text and how can I remove it in Python? And then you have the search component, find the podcast talking about the security issue, and then the generative model takes the ideas and creates like a Python code for you to remove security card, credit card numbers and social security numbers and email addresses and phone numbers from your data. So that's the future goal where I want to go. So far, you get the search results, which can also be really cool for the audience to say, okay, that's an interesting podcast. I want to listen in.
Yes, I think there's so many potential avenues that we can hack around on with all of the content that the MLOps community itself has produced, and the ability with these large language models to do stuff on top of it or gain insights from the different stuff.
So big use case what you mentioned is also what we're going to launch soon. So currently it's a closed beta, soon in an open beta is like aggregation and analysis of results. So what you could take is like all the questions you get in Discord, Slack, analyze it and say, okay, these are like the top 5 questions people are asking all the time. And then you can think about like, okay, let's do a podcast on this. So you see a lot of people ask about, I don't know, AI for other languages. And then you say, okay, that's interesting. Apparently there's a lot of interest in this in our different channels. Let's find great speakers talking about how to do AI other than English.
Yeah, I love that. That would be very useful.
And that's almost how news networks are working already, which is what they do is they will usually scour information on Twitter or other platform for opinions people have about a certain topic, and then they'll bring on an expert and take those opinions and challenge those opinions from like all sorts of angles with experts.
Yeah, so when it comes to the work that you're doing at Cohere, one thing that I think about is there's OpenAI, which is probably like it's sucked all of the air out of the room and everybody knows and has played around with large language models probably because of the ChatGPT phenomenon that happened a few months ago. And they have a very strict policy on their models being closed source. And then there are some open source versions that are trying to come out and have come out, like notably like GPT-J, or we have, I think recently Together just open source like Chat Kit or something. I can't remember the naming.
Llama and Alpaca. So open source community is amazing in terms of names.
Yeah, exactly. And so I'm wondering, like, how have you thought about that? Do you talk about that, or is that something that you don't even enter in those discussions at Cohere?
Yeah, of course. I mean, before Cohere, I worked for HuggingFace, which was the central hub for open source models in the space. It's an interesting discussion people have in the community. First, in terms of capabilities, so open source models currently lag behind compared to like a ChatGPT or to Cohere or Anthropic or AI21.
Yeah.
Also, because open source has a challenge, who's developing it? It's often like academics with like some budget, open source, individual maintainers who like really dedicated, but it's like really hard to get like consistent dedication in this space. And also the requirements for these models, I think in the future they become bigger and bigger. So we're teaching them how to use search, but soon they will also be able to use tools. So like some simple tools like a calculator, and be able to plug in like to your calendar, like moving meetings around and communicate with people. I don't know, check flight information, check the weather. So when I ask like, hey, I go next week to Toronto, Canada, what should I pack? It will first check the weather for Toronto next week. say, okay, next week it will be snowing or the sun will be shining, and based on this, I give you a recommendation what should you pack in your suitcase. And I think that's...
Or it'll just put it in the suitcase directly.
Yeah. And
that's the ultimate goal.
Right. And that's, I think, a challenge for open source to really keep up and maintain it and develop it. Second interesting discussion is also security. Like if when the model is out, it's out for everyone, which is on the one side great and positive because everyone can use it without restrictions and without the gatekeeper. But also what we discussed previously, the bad guys also can use it, and there's like no one and no way to prevent them to train the models to create like a really compelling hate speech and then use them at scale on Facebook, on Twitter for the next US election and produce like millions and millions of political motivated tweets, posts, whatever, and flood every aspect we have.
That's a really interesting discussion, mainly because I don't remember if it was Microsoft or Google that released one of the models. It was a closed model, which is it had research access only, if you remember, and then somebody put it on BitTorrent and gave the torrent link to everybody for like the hyperparameters and everything. The entire model was available to everybody. One of the things I've been hearing from a lot of people is there will be more work in open source when it comes to building more sophisticated models by the bigger companies and open sourcing them. And essentially after that attack, or I don't know if you call that an attack because it was by a maintainer, it was done by one of the maintainers of the actual model themselves. And then Facebook put out their Llama model in public. Do you think we are going towards that direction where we'll see the bigger companies putting their models out there for everybody to be able to access them? And if so, how do we maintain security in those things? Or do you feel like, because again, you lose some sort of competitive edge unless you're training your models, because again, there's a question of the models going stale after like a certain point in time. Do you see more companies going towards the OpenAI direction where they have said after GPT-4, which is, we're not going to release the model, 100 pages, but we're not going to give you any information in those 100 pages?
So, I'm a big fan of the open source community heavily contributing, but I'm afraid it's going more to like closed APIs. On the one side is the cost, like, for these foundation models, it's like tens of millions. So it's like it's really generous that Google has been putting out so many great models like Birch, T5. But it's like, you need to think about like you invest as a company like 50 million in the development of a new model. Is it reasonable to put it out for free for everyone? So that's where you need like really good income stream from ads on Google search to be able to do this. But for many others, it's like really hard to do this. So what you see, sadly, a lot of these newer models from the big companies, they are like not really open sourced anymore. So Google drastically reduced and stopped to open source models. So all the interesting new Google models, Palm, Chinchilla, Retro, they are not publicly available. Microsoft is also kind of reducing it. Facebook kind of still does it, but with Llama, it's like non-commercial, restrictive, only for researchers. There was the leakage on BitTorrent. And then, so it's a challenge. The other is like legal and misuse of the models, like, for example, Stability AI with Stable Diffusion. So it was really interesting, really put out a lot of good things in the community. But as a company, they have to file like legal claims in terms of copyright infringements. And also, sadly, Stable Diffusion is used for a lot of bad things to like create pornography of like underage people and like have dedicated models for that of ex-partners where you create like these photorealistic images to put people into like really obscene situations and pictures and then spreading this on social media and say, hey, here's I don't know, Joe Biden, Donald Trump, or whoever runs for president in like really bizarre scene and then spread this misinformation. And this is like also goes back to the company, say, hey, you put out this model which has been used for all these bad things. So it will be interesting from like a governmental perspective, regulation, to see, okay, what's the boundary? Is the company responsible for the misuse? And this can be typically better protected in like a closed API where you can say, okay, it's not possible to create like any pornographic material. So you cannot spread around like pictures from your ex-partners with these tools. That was no open source because there people can do anything they want.
So is the idea then, do you feel like the world that we will be living in is going to be a world of APIs? And is that the main revenue generator you feel, especially when it comes to just looking at Cohere and you say, all right, we're going to go all in on the API and hope that that is what, as you mentioned before, will sustain us. I mean, Google, lucky enough, they have a cash cow in a different part of their business, but for Cohere, it seems like you have to figure out a way to make that API work.
Right. So sadly, we don't have the cash cow like Facebook or Google. So
Not
yet. Would be nice. It opens up a lot more opportunities to do research in open source. But yeah, in general, I mean, in technology, there are a lot of great technologies which are closed source, which we're using every day. When we look at AWS, like DynamoDB, it's not like an open source database. EC2, S3, and so on. It's like everything is closed source. But we're really comfortable to see it as a tool. So you build a web application that needs to scale at a global scale. So you use AWS, DynamoDB, and S3 and EC2, and you're happy to use it as a developer. So I don't think that there's like a lot of demands to say, hey, AWS, we expect everything to open source and give all the tools you have. Or say, yeah, it's an API, I pay for it, I pay a premium for it. But for many use cases, it's a great cloud provider, and I mean, it's really hard to replicate it with some open source free versions.
On the flip side, it's actually AWS that will come and grab the open source stuff and then say, now you got to pay for it.
Yeah, I mean, with Elasticsearch was the interesting dispute. Taking the open source Elasticsearch, make a managed service out of it, and charge it for it. I mean, that's in general a challenge for open source developers, maintainers. How can you still create like a nice, keep the intent, and then try to avoid like the misuse? Because if you're like, at some point you have to pay your developers because they have to live, they have to pay rent, they have to buy food.
Totally.
So if you really want to build something big, you have to find like a way to make it substantial, like make a living with it.
All right, everyone, I just want to jump in real fast because I have a huge announcement. We will be having a part 2 of our large language models in production. The first conference was such a success that we had to follow it up because there were so many incredible speakers that reached out after the first one. I couldn't help myself. So it will be on June 15th, and it is going to be online, so anyone from anywhere can join. But if you thought the first one was good, then boy, are you in for a treat. We have some confirmed speakers already. I'll just go through a list of them. Mate from Databricks, the founder of Databricks and Spark and all that good stuff. We recently just had him on the pod. He's coming back to keynote. You've got Chip Hewen, who is an amazing person and incredible follow on social, sharing so many insights and has been dropping knowledge bombs when it comes to large language models recently. You've also got Scott McKay from mem.ai. You've got the Deep Speed team is going to be there from Microsoft. That is pretty epic. And Sahar Moore from Stripe. Another Stripe alumni is Emmanuel Amison. He's formerly of Stripe. Now he's working at one of these large language model companies that you've definitely heard of, but I don't think I can spill the beans on yet. And We've got Lance Martin, Inez from Number Station, George Matthews from Insight Partners. This is just a glimpse at the whole list. Go sign up. You've got all the details in the link in the description. Huge shout out to the sponsors, Redis, for showing us some love and making sure that this event happens. Argila, Anyscale, Continual, Chroma. Thank you all. And you can expect all kinds of bad musical improvisations in the breaks like I normally do it. And who knows, I may make that I Hallucinate More Than ChatGPT shirt available for sale again. Check it all out. Links in the description. We'll see you soon. As you're looking around and you're seeing all the other players that are in this space, and it seems like every day there's new ones, and they're kind of converging on different use cases and things that you hope to accomplish with the large language models. What are you hopeful about with the direction that Cohere is going in that makes you think, all right, we're distinguishing ourselves because of XYZ, as opposed to all of these models being more or less commoditized?
Yeah, two things. So OpenAI and Azure, they try to use it to get customers locked into like Azure, in my opinion, to say, okay, you have to bring your data to Azure. So at Cohere, we're going a different route and say, okay, we want to bring our models to you where the data is. We're already like on Google Cloud, but also on AWS. It can run in your own environment. We're also plan to expand it more and give more capabilities to customize so that you say, hey, I take the model and I can really customize it for my use case. How should it write? How should it respond? What are the best tools to adopt it? Second big differentiator is a strong focus on text understanding. So we have extremely good tools that allow you to do search, to do text classification, to do like the aggregation. So where you can create a value for users already now because you're able to search on all your podcasts and aggregate questions to see what are like the most common questions to plan for the next podcast. But also to really marry this text understanding with the generate model. So it really understands on your inbox, on your CRM data, on your, I don't know, on your podcasts, what have you been talking about? So if you ask of the model, hey, write a follow-up email to Nils, thank him for the podcast we made, that can go to the transcript of the podcast, understand what have they discussed, go to all previous emails, take it into account, and then really create a personalized response and text for that.
Oh, dude, I can't wait for that. I mean, the hard part is that sometimes you just get blocked by the other walled gardens. Like I know that we've chatted a lot on LinkedIn. And so if I wanted to do that, let's imagine that everything was there. I couldn't do that because of the LinkedIn APIs. It wouldn't allow me to plug into their messages, right?
Yeah, that's a challenge. I mean, we have so many data silos. You have data in, I don't know, Gmail, on your private email, on LinkedIn, on Twitter, on Slack, on
everywhere.
Discord,
Notion.
Yeah. I think, going forward, a big push forward is like, how can you combine it? And they are really interested in the field, or I think the players in the field who can do it are really well positioned. So I think Microsoft is well positioned. They have like Teams, they have like Outlook 365. So that's a lot easier when you have like all your communication in Teams, you have all the transcript in Teams, you have Outlook and Microsoft Office. Google is also well positioned with Gmail and Google Docs and Google Meet and so on. So I think for these players, like access to data will become critical. And then, once we figure out how can the generative model access all your data and all your, like the whole corporation, and you can ask questions like, okay, what are the top feature requests by my users? It checks your Slack, Teams, whatever, Discord channel, analyze it, and then ask like, hey, create like a project plan to implement this feature. How can we improve, I don't know, latency? And then gives you like really compelling project plan on it. You can already check with the database, okay, who would be like good people who worked on such things before, and then already proposed like, okay, this would be like the teams and people I would need. And maybe
where do we need to update the database, or where do we need to update our code?
I mean, big challenge in staffing
Cost
is
reduction as well.
so big challenge in staffing is you staff, well, you talk to the people you know, but in a corporation there are like many more people. Like in Google you have like, I don't know, something like 200,000 people, maybe 100K engineers. Like who's the best person to optimize, I don't know, hardware, like GPU instructions, and you don't know it, you just know the 100 coworkers maybe. But you could look at previous plans, projects, documentation, and say, hey, this random dude from some different country has a lot of expertise and worked on a lot of similar projects, and I propose this person should also join this new project.
Interesting. And this makes me think, maybe it's probably our last question, but wrapping up, what I wanted to discuss was there are two kinds of companies that we're seeing in the space right now. One are the product companies that are building on top of these APIs. One are the companies that are building these foundational models. And while there are some smaller startups, if you still call Cohere and U.com as startups, as compared to, Facebook, Google, which are almost like at a different level in itself, if we still call them FUNG. I'm not sure what their acronym is anymore. What are you focused as a person? What are you more focused towards, and what are you reading more so these days? Are you reading more stuff around foundational models themselves, around semantic search, around neural search spaces, or are you reading more stuff around the product spaces, or what are the apps that can be built on top of this, like querying Twitter and seeing what are people already building with Cohere?
Then so currently spending in general a lot of time with users and listen to users. So a lot of engineers, they fall in the trap, especially in the machine learning community, to optimize certain matrices which are not that relevant. So you have some benchmark and you try to push the accuracy, and you think, okay, if you go from 88.2 accuracy to 88.5 accuracy, that this will make like a big impact with the users. But users, they often have like other needs and requirements and challenges. So they don't really care about like these 0.3 accuracy difference of the ML model. And they have completely different problems. So one thing in semantic search, right now, a lot of people face a challenge how to chunk text. So far, semantic search only works on like short text, like a couple hundred tokens. If you have longer text, you have to segment it to like smaller chunks of 100 tokens each, and like compute the vector, the representation for each of these chunks. And yes, so many people, they face the challenge like, hey, how do I do the segmentation? I have this Word document, PDF document, this clinical note, this patent text, this earning report. What's like a nice chunking? How can I take these 200 pages earning reports from Johnson & Johnson with tables and images and sections and subsections and titles and footnotes and headnotes, and chunk it into like a nice representation to input it to the model? And then they do not really care about these 0.2 difference on some benchmark, but they say, okay, yeah, I chose it because it's really nice and I don't have to worry about chunking, for example. So often you find when you talk with people that other things are more relevant than really these leaderboard chasing and try to be the top on the Kaggle competition or whatever, with the public academic leaderboard you're trying to chase.
Oh, yeah. We've been seeing that since 2020 in the MLOps community. Not many people in that community actually care about Kaggle as much as how am I going to either save my company money or make my company money?
Yeah. I mean, at the end, you want to use machine learning for these two, make money or save money. And that's, often different things. And then, sadly, it's really misaligned, and also bringing back why I switched from academia. So academia is really, in many cases, this leaderboard chasing, creating systems. They're not practical. So they're like mean, in search, there are some systems that takes like a minute or so for a single search query and cost like a lot of money to do. And I mean, I would not use Google if it takes like a minute to give me like the top 10 results, even when it's like, maybe it's better in 1 out of 100, 1 out of 1,000 queries. I would say, no, please give me something that's fast. I can type in, I don't know, I type in YouTube and I want to click on YouTube because I'm too lazy to remember youtube.com.
Yeah, totally.
I mean, that's the most common search query on Google. And so that's where I find the industry setting more interesting, because it takes more dimensions into account, not only like leaderboard, chase, and Kaggle, build like an impractical system that's really good on this arbitrary benchmark, but build a systems people love, like build a product people love and find helpful for their daily work.
I love that product mindset. So you guys got anything you want to promote or mention coming out of Cohere? Any product, or you all hiring? Anything you want to give a shout out to?
Yes, big project when I joined. I'm originally from Germany. German is my native language, and a lot of focus has been in the field in search on English. So on English, we have like amazing models for any other language. Semantic search sadly didn't work. And so first project I've been working on at Cohere was like the multilingual text understanding model, which works amazingly well in like multilingual and also cross-lingual search. So I can phrase a search query in French and find like a Chinese document giving me the answer on that without any translation, which is like super interesting. In Europe, you have many of these multinational companies, and then colleagues in French, they write and document in French, and colleagues in Germany and German, and French in Spain and Spanish. So a lot of information is lost due to the language boundary. And now it's accessible on the one side for search, for the other is like text understanding, classification. So hate speech detection is a big challenge in online gaming. So you put out like, you're a team of 5, you put out a team which is like really successful, get a lot of traction in the App Store, you get a lot of users using it, but sadly people spit out like unfriendly words, hate speech in like many different languages. And it's like really hard to like really do content moderation in so many languages. And as the model understands all the languages, it's now sufficient to provide like 10 examples of hate speech in English. And then the model says, yeah, okay, I understand you want to identify hate speech, unwanted comments, be able to transfer it to like 100 languages. And then you get like really quick, nice solution to really understand and work in this multilingual, cross-lingual setting.
And this is at the risk of continuing this conversation. Since you jumped into that, I mean, how much of your time or the team's time is spent red teaming the models to make sure that you do have that capability?
So with red teaming, you mean like try to do like adversarial attacks and try to...
Yeah, and try to basically jailbreak it, as some people have said.
So this is more a challenge for text generation. I'm supervising text understanding. So here we're not really, we're not really holding back hate speech from the training of the model, because maybe you want to analyze hate speech. So you want to go into user comments and filter out hate speech. So we really want the model to understand it. But because the model is not producing any content, so it's not able really to produce hate speech. So it just says, here's a text. I put it into like the area with hate speech because it's like racist or sexist or whatever. And then you can take the action on it and say, okay, please, I don't want to highlight racist, sexist content on my platform. So for us, red teaming is just not that big of a challenge, but for the generative model, it's a big challenge for the team.
Awesome, Nils. Dude, I look forward to the day when we get to catch up in Frankfurt or Wiesbaden or wherever it may be, maybe in Berlin. We're having a conference in September. I think I may have mentioned it to you, but we should get you to come and stop by and give a talk or something. Cool. I've been trying to get you to give a talk in Frankfurt at the local meetups too. That'll be awesome. this was really cool. And thank you for your time and chatting with us about all this stuff.
Great. Likewise. Really enjoyed to be here. And yeah, looking forward. AI features developing so quickly, and we'll see what we see this year.
Cool. Yep. Right on.